Today we're going to be talking about geometric series. What you see on your screen now is called a power series. A power series is a form of an infinite series. And a geometric series is an infinite series in which one obtains the next term, which you can see here is x, by multiplying by a common ratio known as r. So the common ratio in this scenario would be x, because this is the first term, 1, and to get to the second term you multiply by x, to get to the third term you multiply by x, so the r here is 1. Another way you can write this is called the sum of the geometric series. This form is a over 1 minus r. A is the first term in the series, or 1, and r is what you multiply by to find the next term. So here we have 1 over 1 minus x, because it is a over 1 minus r. The third term is called an expression of a power series. You can see here, over here, that I wrote plus dot 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 x to the nth power. This is called the general term of the series. The general term of the series can be written inside this e looking thing right here, with n, and since it starts at n equals 0 and goes on to infinity, you would make those the top and bottom of the e. X to the nth power is the general term because when starting at 0, like like many power series do, if you plug in 0 for n, then you get 1, which is your first term. If you plug in 1 for n, you get x, which is your second term, and so forth. This is another way of representing a power series. When a power series is not centered at x equals 0, you have to incorporate x minus a, where you would see an x here. So let's talk about making a power series. Here, like the previous example, we have in this form the sum of geometric series, a over 1 minus r. You can see here that your a would be 1, and since it's 1 minus r, your r would be negative x, which would mean that each term in the series is multiplied by a negative x. That would mean that your first term would be 1, and your second term would be negative x, and your third term would be positive x squared. Let's see if that's right. That's right. 1 minus x plus x squared minus x cubed. Similar to the first example we saw, there is an x to the nth in the general term. However, because it rotates off negative, positive, negative, positive, we're going to add something that would make the series alternating. For an alternating series, you would add negative 1 to the nth power. This would turn your series, instead of just being all positive, into negatives as well, alternating. Here's another example. X over 1 plus x. Here you can see your first term would be x, because that's a in the equation, and your r would be negative x again. Similar to the first one, here's your first term, x, and you would move on multiplying by negative x. X minus x squared plus x to the third minus x to the fourth. The thing that really changes is your nth term. Because these power series start when n equals 0, but here you can see it's x to the first power. You would have to have this first term when n equals 0 be x to the first power. That would mean that you have to add your exponent by 1, which would change every exponent in the series by 1, which is what we need if you look at this first example on the page. Using a geometric sum equation, you can find out whether or not a series converges. If a series converges, r must be less than 1, or the absolute value of r has to be less than 1. in this form. Here's an example. This is the first term. This is r. R in this case is less than 1 because it is 1/2, which means that the series converges. This is the first term in all forms when written in E. Because we have a over 1 minus r, we can plug in to find what the series converges to. Here's a, here's 1 minus r, and all you do is solve that equation to figure it out. 3 over 1/2 equals 6. Let's try another example. Here we are given the power series, 1 minus 1/2 plus 1/4 minus 1/8, and so on. Moving forward, we can see that the first term is 1. In any power series, a will always equal the first term. R, you can find by dividing the second term by the first term, is negative 1/2. In any series, you can find the r by dividing a term by the term before it. As r is negative 1/2, we can plug in a over 1 minus r and find what the series converges to. In this case, the series would converge to 2/3. See if you can get that on your own. Now we have some examples for you to try out. Let's see if you can get these. Pause the video and restart once you have tried both of these series. Good. Let's see how you did. In this case, a is 1 and r, because there is no other constant here, a would be 1, and r, as you can see, is 3/5. That would mean that your equation is 1 over 1 minus 3/5, which equals 5/2. If you found this term in your first equation, you would have, or in this equation, you would have a equals pi over 2, but r is also pi over 2. That means that since pi over 2 is greater than 1, the series would not converge to a number, but instead would diverge. Here, we're going to have you write some problems in the power series. This is the geometric sum form, and try and transform it into power series. Pause the video and restart it when you have already tried. Let's see how you did. The first term is 1, and since r is 2x, you would multiply each term by 2x. 1 plus 2x plus 4x squared plus 8x to the third. The general term, since each term is being multiplied by the next power of 2, would be 2 to the nth, x to the nth. Usually some just common sense is good for finding those terms, the nth term. Let's try another example. 1 over 1 plus parentheses x minus 1. Pause the video and restart it when you think you have an answer. Good, nothing too hard. You can see that since this is a positive, your series would be alternating. 1 minus x minus 1 plus x minus 1 squared, and so on. Here's the form for alternating series, and here is the rest of your equation, or your general term. This concludes the video. I hope that you've learned some about how to write geometric series in different forms, and we've done some examples. Good luck for the rest of the year.